Many Bible readers feel puzzled when reading the genealogies in Genesis. They describe patriarchs living for hundreds and hundreds of years. Adam lived to be 930, his son Seth 912, Methuselah 969, Noah 950. What's going on here? Did ancient Bible writers just imagine these incredibly long lifespans? This would seem to be the case, since people today only live into their 70s or 80s, often with the help of modern medicine. These long lifespans must be mythical, right? Well, maybe not. Certain compelling reasons to believe that the biblical authors were recording the actual long lifespans of these patriarchs have persuaded trained geneticists to take these Genesis numbers at face value. The remarkable picture from these lifespans only emerges when plotting them on a graph. After all, a picture is worth 1,000 words. Only then do we see that the average lifespan of these patriarchs who lived before the flood lived an average of 912 years. After the flood, their lifespans began systematically declining, following what's known by biologists as a biological decay curve. A mythical list of ages would be unlikely to take such a predictable, exponentially declining curve. We see that Noah, who was the 10th from Adam, lived through the flood and died at age 950. Noah's son Shem lived 600 years, his grandson 438 years. 5 generations past Noah, lifespans declined to the 200s. Abraham, who was 10 generations after Noah, lived to be 175. We also have Jacob, when he was 130 years old, stating to Pharaoh that he had not lived as long as his ancestors. Jacob later died at 147. 7 generations later, living to be only 120. What's going on with these lifespans? They systematically decline along a familiar-looking pattern that statisticians call an exponential power curve. Plotting their ages does not reveal a straight-line slope, but a curved one. They don't suddenly bottom out right after the flood, nor do they decline eventually. Rather, the lifespans decline along a nonlinear, exponential curve over time, and this curve literally passes every test for statistical significance. Whatever is going on here is not some chance occurrence. Their pattern breaks every possibility of being some fluke. Geneticist Dr. John Sanford of Cornell University, who was part of a team that invented the gene gun, noted that these lifespans fit so tightly along this power curve that 95% of the lifespan variance is explained by the number of generations from Noah. This statistical model matches the biblical data so closely that its likelihood of occurring by chance lies below 1 in 1,000. Now that's uncanny. This exceptionally strong correlation allows us to predict how long people would live based on how many generations they are from Noah. For example, the curve predicts that someone living 10 generations after Noah would have a 90% likelihood of living between 137 and 234 years. Similarly, it predicts with 90% certainty that a descendant alive 15 generations after Noah would live between 100 and 172 years. This model is so powerful that the average lifespans predicted by the model are within 10% of the actual lifespans recorded in the Bible. This close match reaches well beyond coincidence. This leads to an even more stunning realization. The lifespans in the biblical text span over 2,500 years of recorded history, and the original portions of Scripture that include these lifespans, Genesis 5 and 11, were produced by eyewitnesses whose lives overlapped one another for centuries and decades. So how in the world could they be faked? All of the original authors over numerous generations would have to be in on the scam, conspiring together to record lifespans that perfectly declined along an exponential power curve. Like that's going to happen. Think about that for a minute. Why would they even want to do that? If you were going to make up some story about people in the past that you wanted your future readers to believe, why would you include such unbelievable lifespans? Making this myth explanation even less likely, whoever would fabricate this story must have understood advanced statistics. In addition, look at how the lifespans before the flood are stable. They don't follow any sloping trend line. The systematic decline only starts after the flood, suggesting that some aspect of the flood event initiated the downsloping power curve in lifespans. What was it? Dr. John Sanford explains, the mathematical nature of the declining lifespans arose because the biblical accounts are true and are actually faithfully recording the historical unfolding of some fundamental natural degenerative process. The shape of the downward slope should be immediately recognized by any biologist. It is a biological decay curve. Noah's descendants were undergoing some type of rapid degenerative process. There is now very strong evidence that humans are degenerating genetically and have been for thousands of years due to continuously accumulating mutations. This makes it very reasonable to conclude that the systematic degeneration of man that is documented in the Bible was due to mutation accumulation and resultant genetic entropy. A genetic bottleneck may well explain why mutations suddenly kicked into high gear. This occurs when a very small group of individuals become isolated from a once larger population. The few individuals carry fewer genetic variations than their forebears. They now must build each generation using less information in their cellular blueprints. Biologists have watched lifespans decline after bottlenecks in various animal populations, from dogs to guppies. The Genesis lifespan decay curve looks like real biology, which points to real history. Books throughout the entire Bible, written by different authors in different time frames, affirm this history. For example, Peter referred to the days of Noah, when 8 souls were saved through water. Shrinking the entire human population down to 8 was the ultimate genetic bottleneck in human history. This Genesis-based trend line also points to a recent creation. Luke 3 lists a specific number of generations from Adam to Jesus, and the first names on that list coincide with the names in the Genesis accounts. The smooth, systematic decline in longevity leaves no room for hundreds or thousands of missing generations. Even after watching this, many may still hold the popular but poorly defended position that ancient shepherds wrote their dreamed-up family history on animal skins, but it defies reason that ancient writers developed a text that spanned multiple generations, included over 20 lifespans that track over 2,500 years, and include 2 distinct and biologically relevant trend lines from the pre- and post-flood eras. It would be impossible to collude such a statistical phenomenon over generations. So, what are the implications that come from this? Well, for one, this shows that the whole of Scripture fits together, with several books from the Old and New Testaments referring to these genealogies as authentic history. Even Jesus himself referenced by name Abel and Noah as though they were real people. Paul also referred to them historically, and even computed time spans based on these genealogies, treating them as real history. What causes aging anyway? Biologists continue to investigate unknown aspects of aging, but largely agree that accumulated mutations within the body during one's lifetime accompany the symptoms of aging, including wrinkled skin, weak bones, and loss of immune and other system efficiency. If God made Adam genetically perfect in the beginning, then no wonder his close sons and daughters could live so long. The Bible also promises that Christ would be our kinsman redeemer, and breaking apart these genealogies would undermine the gospel itself. Christ the Redeemer had to map back to Adam as the Bible promised. These findings strongly support the historicity and veracity of the Bible, especially the book of Genesis. They suggest that although the longevity of the early patriarchs seem extreme from our perspective, it could have been normal for them. The declining lifespans of the post-flood patriarchs was due to the ongoing degeneration that resulted from Adam and Eve's fall, and were accelerated by the genetic bottleneck caused by the flood. The drastic decline in lifespans immediately following the flood also supports the worldwide extent of the flood, refuting ideas that it was ordinary or local. Because the genealogies and lifespans are linked, they validate the tight father-to-son nature of the genealogies, without gaps, leading to Adam and Eve living just thousands of years ago.
On today's episode of Biblical Genetics, a fascinating phenomenon, something that happens when very old people have children in any population. It's something I call patriarchal drive. Now, that's a long phrase, but it's really easy to understand. It simply is the effects of the biblical patriarchs having children at old ages in the small post-flood population. It's actually going to have some profound influences and implications on what we think about human history. And it's going to change a lot of things and answer some evolutionary expectations surprisingly easily. Now, what I'm about to say is based on an article that I published in a Journal of Creation a couple of years ago. It is now available on creation.com. Look in the show notes for the link. Simply called Patriarchal Drive in the Early Post-Flood Population. In the human species, males and females are different, obviously. But we're also different in the way that we develop. When a woman is pregnant with a girl, there's only about 22 cell divisions from fertilization to the point where the ovaries are finished and the egg cells are in the ovary and they're held in protective custody, sometimes for 45 years before ovulation. One of the reasons this is important is because every time a cell divides, there's more opportunity for mutations to occur. The DNA polymerases that copy DNA, they do make mistakes. They're amazing machines. They only make a mistake like every billion letters. That's ingenious. But they have to copy about 6 billion letters. And in meiosis, they have to copy another 3 billion a couple steps. There's all these cell divisions that happen before eggs are ready. But then they stop dividing. No more mutations from DNA polymerases. Now, there are some problems that happen on the gross architectural scale. You could have breakages, you could have inversions, you could have duplications, so that women are afraid of having children later in life because there's a higher incidence of things like Down syndrome. This is true. But most of the mutation burden actually comes from the father. You see, it takes about 30-something cell divisions before the male's reproductive cells are ready to go. And then at puberty, they start to divide. And they keep dividing until the man dies. And every time those cells divide, more DNA mutations happen. More mutations are occurring, and they build up, and they build up, and they build up, to the point where, theoretically, older fathers should pass on more mutations than younger fathers. But we've also been able to document this experimentally. Older fathers do pass on more mutations. There's an increased mutation burden based on the age of the father to the child. Wow. So if you want to have kids, have them young. Now, I'm saying more mutations, there's not some giant difference. If you have 50 mutations versus 100 mutations, on a percent scale, that's almost nothing because there's 6 billion letters in your genome. A few extra here and there means nothing. But when we're looking at human family trees, and we're looking at like a phylogenetic tree of all the people, those branches on those trees have a certain number of mutations there, and they're countable. And the length of those branches, the evolutionist assumes, is based on the length of time that's occurred. But what if that's not true? What if at some stage in human history, very old people were having children? Well, then the length of branches is not dependent upon the amount of time, it's dependent upon the age of the parents. Patriarchal drive. Now, I love modeling. I've written a lot of computer models. I've published a lot of my computer models in Journal of Creation and a few other places. I love taking a computer program and trying to mimic what happened in human history. It's really cool. But all models are limited. In fact, all models are wrong in some ways. But they're still useful and they're still interesting. So I've made a computer model where I can toggle in how old people are before they get married, how far apart children are, how old a woman is when she stops having children. Is a man allowed to have more than one wife? All these sorts of considerations that affect population growth, I can toggle into my computer program and mimic population growth over time. And so in an evolutionary scenario, I can say, okay, what's the mutation rate? Given the age of a parent, here's how many mutations I would expect. And since in evolutionary history, most people don't have children after the age of 40-ish, there's a pretty much constant mutation rate. But what if we put in biblical parameters? What if we say that Noah lived for 500 years before he had Shem, Ham, and Japheth? And Shem, Ham, and Japheth as the founders of the modern population. What would happen if that was true? Well, the answer is each of the sons would be born with a lot of mutations that were not in Noah when he was born. In fact, Noah, because he was so old, he's the oldest father recorded in the Bible, by far. Because he was so old, he probably passed on more mutations to his sons than all the mutations that occurred between Adam and Noah. In fact, it might have been more mutations that ever occurred in the history of the world, depending upon the conditions, which we don't know much about. We don't know the mutation rates before the flood. We don't know the mutation rates right after the flood. We only know modern mutation rates. And modern mutation rates is a very interesting study in itself because the evolutionists who do these studies, they have to filter data. You can't just take two sequences and compare them. No. You have to say, well, we think there's an error rate associated with this data. And when we're talking about Y chromosome specifically, the Y chromosome is 60 million letters long. And most of that is not considered. It's too variable. There's only 10.4 million letters in the Y chromosome that are used for evolutionary mutation rate estimates. The rest of it, they just get rid of. But even that 10.4 million, they filter the data out. Well, we think that the error rate is this, therefore we're going to take out so many letters. So there's a lot of assumptions built into this. There's actually a lot of art inherent in this science. You can't just read a scientific paper and say, this is the mutation rate. Because if you could know that mutation rate, wow, you could run all the way back in time and say, how long would it take to build up all the mutations we see in the human population? But we actually can't know. But it's even worse when you put in patriarchal drive, because you cannot know the early mutation rate if really old men and women are having children within a small population. So what I did was I created 3 different models. One with a linear mutation rate, one with an exponential mutation rate, because we only know the mutation accumulation for people within modern lifespans. Yeah, older fathers have more mutations than younger fathers. Okay, but we don't know anything about a 100-year-old father or a 200-year-old father or a 600-year-old father. So is it just like X number of mutations per year, or does the rate start to accelerate as a father gets older? So what I did is I created 3 separate models, and I ran each of them in my biblical model to see what would happen over time. And what I found was that indeed, not only did older fathers contribute more mutations, but early on in post-flood history, some years the average mutations gained is huge. I mean, the order of 30 to 50. That's the average. So if a father has a child and he's a young father, that child only has a couple of mutations. But if an old man has a child, has a lot of mutations, the average is 30 sometimes. 30 new mutations. Today you might expect 0.5. So early on we have an accelerated mutation rate, a highly accelerated mutation rate. And if we're talking about an average, that means that some of the fathers are pumping out children with a lot of mutations, while some are pumping out children with only a few. What that means is that the center branches of the tree are arbitrary. You cannot know that the length of that branch equals so many years, because it might equal the length of the age of the father. Other interesting things that occur when you model things. I figured out that if you look at the number of generations removed from the patriarchs in the population over time, let's say like at year 1000, year 2000, year 3000, and year 4000. Well, by the time you start getting up there, there are some people that are the oldest child of the oldest child of the oldest child of the oldest child. And there are some people that are youngest of the youngest of the youngest of the youngest. And so the number of mutations separating people later on in the model from the first people in the model means that at year like 2000, there are some people who are more mutations removed from the beginning than there are people at year 3000. Let me give you an example of this generational overlap. Right now, today, 2 grandsons of President John Tyler are still alive. John Tyler, he knew George Washington. He was born in the 1700s. He was president of the United States in the early 1800s. 2 of his grandsons are still alive? Yeah, because he had children when he was a really old man. He had a second wife when he was an old man. And then his son also had a second wife as an old man. And 2 of the sons of that last marriage of that old man are still alive. So we go from someone born in the 1700s, his grandchildren are still alive today in the 2020s. That's nuts, but this happens, and it's a really cool phenomenon. If those men today had children as really old men, their children would have a lot of mutations. Now, it wouldn't make a difference now because there's 7 billion people in the world. But right after the flood, there was only 6 people. And even hundreds of years after the flood, there's only a few thousand people. And so these old patriarchs are having children in a small population. And in an exponentially growing population, you don't lose a lot of lineages. Today, most people have 1 or 2 kids. Well, most of their family lines will go extinct after a couple of generations, specifically Y chromosomes or mitochondria. I mean, I have 1 son. My second cousin has 1 son. There's only 2 Carter males alive that I'm aware of from our great-great-great-grandfather who came over from Ireland. So my Y chromosome is nearly extinct. I don't know if the next generation will be here anymore. In exponentially growing populations, though, most lineages remain, because if they didn't, the population wouldn't grow. So as it grows, those lineages are there. So if we look at the family tree, say the Y chromosome family tree, and we focus on the middle of the tree, the center point, the point where people are just starting to radiate, those big branches are quite possibly due to old men and old women. Cool. So forget about the molecular clock. Forget about deep time. And take a fisheye approach to the phylogenetic tree. We probably have to shrink those center branches to make them shorter if we want to represent time. And the mutations are there. That is mutations. That is a mutation count. It is the number of letters that separate these people from each other. Taking the biblical idea that people lived a long time in the past contradicts the evolutionary assumption of a molecular clock and helps answer questions about evolutionary phylogenetic trees. The Bible can be trusted. We don't have to hide from it. We don't have to throw our faith away every time an evolutionist comes up with a new chart or figure or table. In fact, when we look at the number of mutations that separate men from each other today, we can actually use the evolutionary mutation rate and say, yeah, the Y chromosome Adam of the world only lived a few thousand years ago. If you take away a lot of their data filtering, the Y chromosome Adam of the world population lived very recently. And if you factor in patriarchal drive into this, it is easy to put Adam, in fact, we should be calling him Noah. It's Y chromosome Noah. It's easy to place Y chromosome Adam or Noah in the biblical time frame about 4,500 years ago.
Looking for answers about what the Bible teaches about creation, the fossil record, dinosaurs? Download the Genesis Apologetics app from the iTunes or Google Play stores for answers to these questions and more.